right, today we're going to talk about zeros, linear factors, and multiplicity, and this is going on page 49 when we're done. So we're first going to talk about zeros, which are not new to you. We've already talked about them and found them some, but we're going to talk about some other details, hopefully, which are reviewed to you. So the x-intercepts of a function are also called zeros. We can call them a few other things, but zeros is definitely one of them. A polynomial, not any function, but a polynomial function of degree n can have at most, that doesn't mean exactly, it means not more than, at most n real zeros. Okay? A polynomial of degree n has n zeros, but at most in real zeros. That word real there is important for us because those real ones are what we're actually putting on the x-axis. So if I have a fifth degree polynomial, it's possible that I could have 5 x-intercepts that I can actually graph. But maybe I don't have 5. Maybe I have less than that because some of them aren't real zeros. So there's where that word real makes a difference in the definition there. Okay, so if I have an even degreed polynomial, right, even degreed, x squared, x to the fourth, hopefully we know what even numbers are. An even degree polynomial has an even number of real zeros or no real zeros. Okay, so an even number of real zeros. So if you're trying to tell me that a fourth degree polynomial has 3 real zeros, that makes no sense. Because it's either going to have, if it's at fourth degree, it's either going to have 4, 2, or 0. That's going to be important for us moving forward here. So if I have an 8th degree polynomial, it's either going to have 8, 6, 4, 2, or 0 real zeros. Okay? For an odd degree polynomial, an odd degree polynomial has an odd number of real zeros. A 7th degree polynomial could have 7 real zeros. That's a possibility. But it could also have 5 or 3 or 1. Impossible for it to have 0 zeros, 0 real zeros, or an even number. Okay, so remember the key here is the real zeros part of that. All right, so then let's talk about linear factors and solutions. The solutions to the equation f of x equals 0 are the zeros of the function. So our zeros can also be called solutions, and they can also be called roots. So roots, solutions, zeros, all that kind of same thing. So if x equals c, c being the constant, so if x equals 5, so if x equals c is a solution to the equation, then x minus c is a linear factor. Why do you think it's called a linear factor? Well, this is x to the first power. So it is a linear factor of the polynomial function. Linear factors can be found by factoring the polynomials. I hope you are factoring whizzes at this point because you're going to need that for what you need to do. Got to be able to factor. And remember, if you're not a factoring whiz, if yesterday you were a little freaked out and it wasn't easy for you and you weren't just bored because why are we going over this again, then you need to spend some time on Khan Academy getting this figured out because you don't want that to be what's holding you up in any aspect. All right, so for example, we have f of x equals x cubed plus 5x squared minus 24x. It's asking for the linear factors, so we're going to have to factor it. So I'm going to come over here, because we have room, there's really no room to factor it. Let me rewrite the expression part of that. X cubed plus 5x squared minus 24x. Okay. So I'm going to factor out my GCF. Always find the GCF first. X squared plus 5x minus 24. So as a reminder, some of you may need a reminder of this, some of you may not. This would be x, this would be x. If this is negative, these signs have to be opposite. They have to be different to multiply to give me a negative. Since this is positive, the bigger number is positive. So they need to multiply to give me 24, and the difference has to be 5, so that would be 8 and 3. So when I factor this, if I'm given this, this equals x times x plus 8 times x minus 3. So that's the factored form. It says, what are the linear factors? Well, these three factors here, those are my linear factors. So x times x plus 8. No, well, I don't want to do it as times. Sorry. I was trying to list it, and then I got ahead of myself. So x is 1, because it says, what are they? It's not asking me for this. So x, and then x plus 8 is another linear factor, and then x minus 3 is another linear factor. Okay, so I've got 3 linear factors. So since those are my linear factors, my zeros, okay, now it's asking me for zeros. It does not say x-intercepts. If it said x-intercepts, then I would write those as ordered pairs. When it says zeros, that's when we have our little set notation, like so. So this one's going to give me a 0. This would be negative 8. This would be positive 3. So to put them in order, we've got negative 8, 0, and 3. There are my zeros. Zeros is a different answer than x-intercepts. Yes, they're representing the same thing, but you answer the question differently. All right, so we're supposed to find the zeros of the functions below by factoring. So I need to factor. So I've got to factor out my x here. That makes it nice. X squared plus 3x minus 10. So then this gives me x and x. This is negative, so the signs are opposite. And I need the two numbers that are multiplied give me 10. Well, there's not a whole lot to choose from. Positive 5, negative 2 there. So that means f of x is equal to this right here. So then it says find the zeros. Here's my factored form. I want to see your factored form. And then my zeros will look like this. It's going to be 0, negative 5, and positive 2. So negative 5, 0, 2. And there you go. All right, so we're going to factor this next one. We get x times 2x squared minus 5x minus 3. So again, if you want to do your divide and slide or whatever, you can go ahead and do that without me. I would suggest grouping if you don't have a favorite, just because then it's consistent. So if because there's no GCF besides x, well, I'm sorry, x is the GCF. There's nothing else I can factor out. So that's going to give me 2x squared. Well, 2 times 3 is 6. So I need them to multiply to give me 6, but combined to give me a negative 5. Signs have to be opposite, so it's going to be negative 6x, and then a 1x, or just x, either way, and minus 3. So when I actually go to do the grouping, I would put brackets there so I don't get lost in my parentheses. These two, I'm going to get a 2x out. That leaves me with x minus 3. Factor out here, I would factor out a 1. That gives me x minus 3. Then I can lose the brackets, and f of x is equal to x times x minus 3 times, times 2x plus 1. Once it catches, yeah, 2x plus 1. Okay, so there is my factored form. My zeros. So I've got 0, positive 3, negative 1/2. If you need to actually write them out to solve them, you can. But I've got negative 1/2, 0, 3. Okay. All right. So I'm going to factor this next one without talking you through it. I don't want to necessarily just pause this, but I want you to try and factor this without looking up here, and I'll give you some time to kind of get that done before I start talking and move on. But I am going to write it up here while you try and look at your paper. Try not to look up here and factor this on your own. So I think the exact same problem was on the notes yesterday. I didn't mean to make them exactly the same, but I guess I just randomly picked that. When you factor this into the two binomials, that shouldn't be anything that's a big problem for you because you can just treat this like a quadratic. Then when you get here, you got to keep going because those are difference of two squares, so we end up with this. Now, I'm going to have 4 zeros to write down. I can write them down individually, that's fine. But when you have the same one, like this is going to give me a negative one and a positive one, so I can just say a plus or minus 1 and plus or minus 2. And that takes care of all 4 of them without writing them all out. It just makes everything cleaner, especially when we have to list a bunch of them, which we will eventually get to. Okay. All right, so then same thing with this one. Go ahead and try and factor it without me. You're going to have to do some maybe grouping and pretend like it's a quadratic that way, but you can do this. And I'll write it out without saying anything, so it gives you some time to think. Okay, so that's what I get when it is factored. Okay, so again, might not look exactly like stuff you've done a ton of. Maybe it does, but I treat this like a quadratic as I do my grouping. And then once I get here, I have the difference of two squares twice again, so I can keep going, and I get those 4 factors there. And then once again, when I solve for x, this is going to give me a negative 1/3, positive 1/3, so I can do plus or minus 1/3, and then negative 2, positive 2, so plus or minus 2. So you've got to be able to factor, find your zeros. I want to see the factored forms, and I want to see the zeros. Okay? All right, on the other side. Got f of x equals x cubed plus 5x squared minus 9x minus 45. The same directions are the same. I got to factor and find the zeros. So there's no GCF here. So I'm going to start with my grouping. And here I can pull out an x squared. Gives me x plus 5. Here I can factor out a negative 9, so negative 9, x plus 5. So I get x plus 5 is x squared minus 9. I can keep going. X plus 5 times x plus 3 times x minus 3. That is my factored form. My x for my zeros is going to give me a negative 5, a negative 3, and a positive 3, so negative 5, and then plus or minus 3. So here, I'm going to factor by grouping again. We should be experts at all of this now. So I want to factor out, remember, make sure you factor out the GCF. Yes, I can factor out the x squared. I could also factor out a 2. I could also factor out a 4. So we're going to go 4x squared. It's going to give me 5x minus 3 minus 1 times 5x minus 3. So then 5x minus 3 times 4x squared minus 1. So then I get 5x minus 3. This is the difference of two squares again, so I get 2x plus 1 and 2x minus 1. That's my factored form, f of x there. Looks like that. So my zeros, this is going to give me a positive 3/5, negative 1/2, positive 1/2, so plus or minus 1/2, and then just a positive 3/5. All right, so that should be really, I mean, you should have factored and found zeros a ton last year, so that should all be pretty simple and hopefully a total review to you. So let's talk about multiplicity. Multiplicity of a zero, so the multiplicity of a zero is the degree of its corresponding linear factor. Okay, so it's the degree of the linear factor, not the degree of the polynomial. So we're going to find the zeros of the functions below and state their multiplicities. So we're still going to factor and find zeros. We got to start that way. So here I'm going to factor out my x. This gives me x squared plus 10x plus 25. Okay. Then you can factor this like you would normally factor things, but a is 1. If I can take half of this as 5 and square it, I get 25. That means that this has to be x plus 5 squared. And again, if you don't recognize that, it's fine. You can factor it into x plus 5 times x plus 5, but then it needs to be written as x plus 5 squared. That is the factored form of this polynomial here. So our zeros, we're going to list them out a little bit differently here because we're talking about multiplicity. So I have this would give me a 0 and this would give me a negative 5. But here I've got two of them, right? So when x equals negative 5, it's true that x equals negative 5, but my board is not cooperating and I just wanted to move it up a little bit. So x equals negative 5. In this case, the multiplicity of 2, because there's two of them, multiplicity, how many multiples of them are there? And then x would also equal 0, and that is the multiplicity of 1. Okay, so that's part of my answer as well. Number 8. So x to the 4th is negative, so I'm going to have to factor out a negative, and then my GCF will be x squared. So negative x squared times x squared xx plus 9. Watch your signs. And so then here, again, I can factor this like I factor everything else, but if a is 1, if I take half of this, that's 3, and square it, I get 9. It's a perfect square trinomial, so negative x squared times x minus 3 squared. That is f of x. Okay, so that is my factored form. So then my zeros, this would give me 0, so x equals 0, and that multiplicity is 2, so multiplicity of 2, and x would also equal 3, and that multiplicity is also 2. There we go. Okay, so that's what it means by multiplicity. So let's talk about the multiplicity and the graphing, which we've already kind of been introduced to. So we want to write f of x equals x cubed plus 4x squared plus 4x in factored form, and graph the function, then look at how the multiplicities affect the graph. All right, so I'm going to rewrite the expression over here. I got x cubed plus 4x squared plus 4x. Okay, so I factor the x, get x squared plus 4x plus 4. Well, once again, a is 1, half of 4 is 2, square it and get 4. So that means I get x times x plus 2 squared. So the factored form then is f of x is equal to x times x plus 2 squared. So it says graph. We're really sketching. So let's remind ourselves about the sketching part that you actually turned in today. This is a cubic, so it's a third degree polynomial, right? My highest exponent is 3, which is odd. So the end behavior is opposite. And since this is positive, my end behavior is going to look like this. This is important for us to know what to graph. Okay, my zeros, okay, we can write them out as intercepts, but we've been writing them as zeros. So my zeros here are 0 and negative 2. But remember, we've already talked about what happens when you have a factor that has an exponent that's greater than 1. So if it was even, we either had a bounce or a wiggle, right? And so at this one, this is a bounce. And then we need our y-intercept. Well, since one of your x-intercepts is 0, then your y-intercept is 0 as well. So we come over here to graph this. Just go to 1, 2, 3, 1, 2, 3. And so my zeros, I'm at 0 and I'm at negative 2. Right? And so this is what my end behavior looks like. So I'm going to come up from negative infinity. But I have a bounce at negative 2. So it comes up from negative infinity, it bounces off the x-axis, and then we're going to have to come back up through that intercept, and I get a graph that looks something like that. Okay, so there's my graph. Here are my zeros. A little bounce there. Remember, your bounce is not like a V. It's not a point there. Everything is a smooth curve for a polynomial. So here's what we know. We have said that when the multiplicity is even, the graph is blank to the x-axis at that 0. So we've said, and what I told you the other day was, this is where we get our bounce from, right? But that's not a technical term. And bounce wouldn't fit in the blank. We can't say the graph is bounced to the x-axis. Makes no sense. So I want you to think about what word actually goes in that blank. Just think for a second. When the multiplicity is even, the graph is blank to the x-axis at that 0. So when this comes up, how is this graph related to the x-axis at that point right there? Because does it intersect the x-axis? Yes, it does intersect it, but it intersects it exactly 1 point, comes down, and that's when we say it is tangent to the x-axis. So we've got a point of tangency there. So really that even multiplicity makes it tangent. It's still a bounce because I want you to think about what it looks like, visually, but tangent is how it's actually related and how we need to think about our curves with our lines. Okay, so if the multiplicity is 1, okay, multiplicity is 1, bam, then the graph intersects the x-axis at that 0. And I just realized I really don't like that word there, because when it's tangent, it intersects it also, because it has a point in common. This intersect really means that we really should be saying, I guess, that it passes through, because not all intersections are a pass-through. Bad wording there. All right, so it passes through the x-axis at that 0. Now, when the multiplicity is odd, which is also when it's 1, but when it's odd and greater than 1, okay, the graph still passes through since it's odd, so it still passes through, but it has something that we know, because we already talked about this, we didn't just use the cute word with it. It has a point of inflection. Point of inflection on the x-axis at 0, and that's what we called our wiggle when we sketched them. Point of inflection. My handwriting is terrible. I'm going to rewrite that. Point of inflection. Oh my goodness. I don't know if that's any better, but inflection, point of inflection. All right, so a couple more examples here. It says, identify the zeros, their multiplicities, and describe the effect on the graph. Okay, so in order to do that, I've got to factor it, but oh yay, number 9 is already factored for me. So I can just get my zeros. So this is going to give me a positive 1, positive 3 halves, negative 4. So negative 4, negative 1, oh, not negative 1, dang it. Positive 1. Negative 4, positive 1, and a positive 3 halves. So our zeros, we'll start with, our zeros are negative 4, 1, and 3 halves. So the multiplicity, the negative 4, this one right here, the multiplicity is 1. The 0 of 1 has a multiplicity of 2. And the 3 halves has a multiplicity of 2. So the effect that it has, when the multiplicity is 1, it just passes through. If it's 2, yes, it's a bounce, but it is tangent to the x-axis. And both of those are 2, so they are both tangent. Okay. All right, so then number 10. So number 10, I want you to go ahead and, again, let's factor it on your own without me talking you through it. And don't look up here while you do it. Okay, it should not take you long to factor something like that. You can't get, all this can't tie you down too long because you're having to think too hard about it. Whether you know the fact that it's a perfect square trinomial or you still just do the factoring, you should still be able to get here pretty quickly in this form so that these are my 2 zeros. Okay, so my zeros are negative 4 and 0. There's not a third one, so that third line is going to be blank, and that's fine. So the 4, negative 4, has a multiplicity of 2. The 0 has a multiplicity of 3. So the even multiplicity gives me a bounce or a point of tangency. So it is tangent to the axis. And then here, since it's odd, it still passes through, but it passes through at a wiggle, which we call the point of inflection. Point of inflection. Okay, on your assignment, I want to see the process of your factoring. I'm not saying that you have to show me every single step. I never tell you that ever. But what I am saying is that if you have something like number 5 here, you're not just going to have this and then all of a sudden jump to this. Like, you're not doing all of that in your head all at once. I don't believe that for a second. Okay, so you got to show me something in between. Make sure I see the factored form, that it's actually equal to f of x, because this is an equation. I mean, I'm not making you rewrite f of x each time because we have this equals here and you can follow the process, but in the end, this is what we have, and then make sure that your x's are written appropriately as well. You know what to do and know how to do it. Read the directions, use your notes, and get this done. This should not be crazy hard for you, but you need to be able to factor, okay? We'll only get more factoring from here. Now I want you to actually work when you get your assignment, either on this or what is due tomorrow, but work and be good and be nice to Miss Williams. I will see you tomorrow.